Hi, cool coders. Today we're going to be looking at lists and tuples and how you can use these to manage large collections of data, and then how you can use code to manipulate large collections of data using something like a loop. So this is some pretty fundamental stuff that we use a lot in programming. So let's dive right in and look at what these are and then how you can use them in your programming. First concept I want to look at is a tuple. Now, a tuple is a collection of data that is unchangeable. Now, a list is a collection of data that is changeable, and that's pretty much the key distinction between these two. So changeable, we call that mutable, and unchangeable, we call that immutable. So you might see these words used instead of words like changeable and unchangeable, but they basically mean the same thing. So unchangeable is immutable, changeable is mutable. And that's pretty much the key distinction between these two. And there are things that they will have in programming that we'll look at through the duration of this lesson, but we can treat them very similarly, and that's what we're going to do through this lesson. And we'll be talking about the differences between the two and the similarities between the two as we go along. In code, we will see a tuple denoted by parentheses, and you will denote that using a set of parentheses and then assigning that to say something like a variable. And inside of those parentheses, you would have some kind of values that are separated by commas. So that can be string data like we see here, or that can be numeric data like we see here. So lists are like tuples in that they are a collection of data, but as I mentioned, this set of data is mutable or changeable, and we'll get more into that as we go through the lessons and what that means. But the denotation for this is very similar to that of a tuple, but instead of using parentheses, we're going to use square brackets. And my syntax is going to look something like this, where I have a variable and I'm going to assign that to square brackets. Then inside of my square brackets, I'm going to have a list of values that are comma separated. In this case, I am using string data. And in my second example here, I am using numeric data or integers. Before we go to Tony, I wanted to introduce you to the idea of an index. An index is basically a number that points to a specific value inside of your list or your tuple. And since it's a number, it can be positive or negative in the language of Python. A positive number is going to point to the first item in your list and then go from the first to the second, third, and so on. And this is used to reference them in the order in which they appear in the list or the tuple. And the first index of any list or tuple is going to be 0. So this can be a little bit confusing for folks. They will think that the first item in a list should have an index of 1, but it uses what we call zero-based indexing. And therefore, the first item will have an index of 0, the second one will have an index of 1, and so on. So you can think of it as whatever the cardinal number for that is, say first minus 1, and then that will get you the index in your programming language. Some languages use 1-based indexing, but Python uses 0-based indexing. So just make sure that you're referencing that according to the appropriate indexes for the kind of language that you're using. And in our purposes, because we're dealing with Python, we're using 0-based indexes. Now, negative indexes inside of Python start at the end of a list. So -1 will return the last item in your list. So that's can be a little bit confusing for folks. They say, well, the negative index starts at -1. Why doesn't the positive index start at +1? And that's because the positive index starts at 0 to not waste space inside of our number line. So just get these two sorted out in your mind before we get into this. Oftentimes, though, you're probably not going to use negative indexes a lot. You're going to use them sometimes. You usually use them to fetch things at the end of a list, typically the last item in a list, as I've used it in most of my experience. But most of the time, you're going to be using positive indexes anyway. And that is because it's just the one that's most natural, and it's the one that you're going to be looping over anyway when we build our code. So we're going to start at the beginning of the list and go to the end. There are some cases you want to start at the end and go backwards, but most of the time it's going to be at the front of the list and going to the end, or the front of the tuple and going to the end. So let's look at some examples of this that I have on my slide. Let's imagine I have this tuple called alphabet, and I've got A, B, C, D, E, and F in my tuple here. And if I wanted to print the first item in my list, I would give it a index of 0. And notice what I have there. I have alphabet, and then I have square brackets, and then I put the index inside of those square brackets. And this one is going to output A, because that's the first item in my index. And if I had the alphabet referencing the second index, so I would get C in this case. So print alphabet 2 is going to give me C, because that is actually the third item in my tuple, but I'm getting the index of 2. So it's the third item, but it's actually the 2 is the index. So think third, 3 minus 1, and that gives me the index of a zero-based array. And then if I went with -1, this is my negative index, I wanted to get the last item in my tuple here, I would simply do alphabet -1 there, and then that would give me F. For most purposes, though, we're going to be looking at positive indexes, although, again, there are use cases for getting things from the back of the list or the back of the tuple and then going in reverse order. I'm here inside of Tony, and I want to create a couple of lists and tuples to demonstrate what we have been talking about thus far. So let's start with a tuple. So I'm going to start off with alphabet tuple like that, and I'm going to assign that using parentheses, and then I'm going to put in my values, A, and then B, and C, and D, and so on. So when we talk about indexes, we can have a set of data to work on. So that's my alphabet tuple, and I'm going to basically clone that, and I'm going to call it my alphabet list. But the difference with this one, again, is square brackets instead of the parentheses that I have up here in my tuple. So if I run this, both of these will run. It's not going to do anything. It's basically just creating some variables over here. And if I look at my variables, you can see these over here inside of my variable list. They're basically the same data. It's just one is a tuple and one is a list. And so let's go ahead and do some code on these. Now I can do a print of these. This is something you can always do with either one of these. You can just simply put in alphabet tuple and it will print that out, or I can print out alphabet list and it will print out the entire list for me into the console down here, into my shell. So it's just printing out the literal output from my declaration up here of my variables. So alphabet tuple and alphabet list. So that is one way to get the values, or you can use the variables output up here as well to kind of see what's going on inside of your lists or inside of your tuple. So let's do some indexes on these. So let's look at the alphabet tuple here. Let's do print, and I'm going to do alphabet, and I'm going to put in alphabet tuple, and I'm going to put in an index of 0 here. And that was going to probably print out, as you expect, the first item in our tuple and then our first item in our list, which would be A. And that's exactly what we have right here. So let's add some other types of indexes to this. And let's say the second index, or the 2 index, or the third item inside of our tuple or our list. And that's going to print out C. So both of these have the value of C as the third item in the index. And let's look at the negative indexes as well, just so that we can see what's going to go on with these. So let's do a -1 here and a -1 here, and I would expect that to print the last item in both our tuple and our list here, and that is going to give me F. So let's do a -2 on this to see what happens, which we would probably expect that to give us the second to last item, which is going to be, in this case, E. So let's print that out, and just so we can see what's going on, and there we have E. And so our last item, that is F, gets a -1 index. Our second to last gets a -2, while our positive indexes start at 0 and then go forward. So 2 actually points to the third item in the list, and that can be a little bit confusing for folks that are getting into this, as I mentioned, but just try to understand that everything in the positive space, when we're talking about positive indexes, starts with 0. So the index for this, although it's the third item, is going to be 2. So I'm going to say that over and over again, just so that you will be very familiar with that, so that when you think, oh, I want to get the third item in the list, I got to think index 2, or I want to get the first item in the list, I got to think index 0. I want to revisit the idea of ranges again. Now, we've seen ranges before when we looked at for loops, and with a for loop, we'd set up a range and we'd say, I want to loop over a given set of numbers. Say I wanted to loop over 1 to 9. So I would set up a range that would say start at 1 and go up to, but don't include 10. So my range would be 1 to 10, and that would give me 1, 2, 3, 4, 5, 6, 7, 8, and 9. We're going to see similar behaviors inside of lists and tuples when we talk about ranges as well. Ranges in the context of list tuples are used to return subsets of data. And to do this, I'm going to be using indexes. So the indexes can be both positive and negative in the references that we've seen already. And I can also use those in ranges as well. So let's imagine for a second that I have a tuple that looks like this. It's called alphabet and it has A, B, C, D, E, and F in it. And I want to get specific ranges out of this. So let's look at our first example here where I have a print command that says print my my 0 index and my 2 index. So that's going to be the first and third item inside of my tuple. So this is the last index that I want to go up to but not include. So this is going to give me the first index of 0, the second index of 1, but not include this one. So this range is going to basically give me these two elements inside of my tuple here. And so therefore I'm going to get the output of A and B right here. So on my next example, I have a print command that says, give me 2 to 4. So this is the third item and this is the fifth item inside of my tuple. So again, I'm going to start right here in this case, and I'm going to go to the index of 4, and that's the fifth item in my list right here. So it's going to give me this range right here, and therefore I'm going to get this output as well. So let's look at an example where I use negative indexes. So I'm going to get alphabet -3 to -1. Notice what this is doing. It's starting with the lesser of these. So it's starting with -3. So remember that this is -1. So this is going to be -3 right here. So this is going to be this item, and it's going to go to -1. That is the last item in my tuple right here. So this is going to give me this range right here. So it always goes from left to right, even when I'm dealing with negative indexes for building out my tuples as well, because of the first index being less than the last index that I'm using to specify whatever it is I'm going to be doing with my tuple. So this can be a little bit confusing for folks. Most of my experience has been using the positive indexes to get data out of my tuples, but in some cases there might be a use case for getting the end of your tuple or your list as well, and you'll get some output like that. So let's go over to Tony and take a look at these inside of code. Okay, I want to get some values for my lists and tuples here. So I'm just going to steal this code from my list and tuples example. So I have my alphabet tuple, my alphabet lists, and I'm going to create a couple of print commands here inside of Tony that'll print out a couple of ranges. So let's start with our alphabet tuple, and I'm going to get a range for this. So let's start with 0 to 2, and this will give me the first item or the index of 0, so it's going to give me A, and then go up to the index of 2 or the third item, and that will give me A and B. So let's print that out just to make sure that I'm not lying to you, and that's exactly what we got. And similarly, I'm going to do that for my list as well, and we'll see exactly what's going on there. So let's do list like that, and that will give me my list instead of my tuple. Notice the square brackets there. So again, the same concept just applied to a list. Now let's do the example that I had on the slide where I have 2 and 4, and just so that we can see this one in action as well, and 2 and 4 here. And so this is going to give me my third item or the index of 2. So it's going to start on C respectively and go up to the fifth item or the index of 4. So it's going to go to E here. So it's going to go up to E but not include E. Let's run that and make sure that's exactly what I get. And so I'm just getting C and D. So let's do some negative indexes and see what happens with these examples. So let's do what we saw on the slide. Let's do a -3 and go to -1, and do a -3 and a -1. And this will give me a range. It's going to start at the -3 index right here, and then go up to but not include the -1 index. So that would give me the D and E. So let's run this and see what happens. And that's exactly what I got here. So you can see here, this is how ranges will be useful for getting subsets of data out of lists and tuples. Now, you don't have to hard code values like this. You can use variables inside of these values as well if you want to make this more dynamic, but this is how they work. And this is a useful tool for getting subsets of data out of your existing tuples and your existing lists that you already have defined. I want to revisit the idea of the for loop again, and I'm going to be talking about it in the context of lists and tuples. You can use for loops to loop over the items inside of a list and tuple, just like we did with the items inside of a range that we built whenever we were talking about for loops last week in our lesson then. So the code is going to look very familiar to us. So we're going to have our tuple, in this case, our alphabet tuple, and I'm going to have the items A, B, C, D, E, and F. And instead of giving it a range here, I'm going to say for, there's my variable called letter in alphabet. And instead of specifying a range here, I'm just going to give it the name of my tuple or the name of my list. And then I'm going to do something with each item inside of my tuple or list. So I'm going to go I'm going to print out A, B, C, D, E, and then F using this command here. So it's going to go over every item in my list, and once it gets to the end, it's going to exit the loop and then continue exiting my program. So let's go over to Tony and see this in action. Okay, I'm back here in Tony and I have a new file open. I'm going to grab this data again from my ranges demo here, and I'm going to paste it in so I have some working tuples and lists to work with. So I'm going to set up a for loop here, and I'm basically just going to print everything like I did in the example on the side. So for letter in my tuple here, and I'm going to set up a new code block indent, and then I'm going to print letter. And as you might expect, that's simply just going to print the tuple full of letters and just each individual item inside of that given tuple right there. And the same thing would happen if I did the same thing for a list here. So if I did a list, I can do the same thing here. So I would just simply get the list printed out as well. If I wanted to do a range, like if I wanted to only print out a specific number of items in this, I can do a range that looks like this, where I have 0, and let's just say 4. And so that's going to give me the 0, 1, 2, 3, but not give me the last 2 items in this particular list here. So let's run this and see what happens. And that is what I have, A, B, C, and D. So I've got everything up to the 5th item in my list specified by index 4, but not including that one. So you can see how I can use that for this range right here that I have specified as well. So I can use it across the entire tuple or the list or just a subset of that as well. So this is how you can use for loops with your lists and tuples. It's very common to do this, so it's something that you'll want to get used to doing whenever you're writing code in Python. The next concept I want to talk about is searching for items in a list or a tuple. Now, there are 2 kinds of ways to do this. One is to say, does it exist inside of a particular list or tuples? And that's where I can use the in keyword. And I can also use another function to get the index of a specific item in a list. So that would be the index method. So if I wanted to search for something inside of a list just to see if it's in there, I would set up some code that looks like this. So let's say I have my alphabet tuple again, and I said if C by value is in my tuple or my list, then I can say true or false. And it's a print C is in the alphabet. And so that's going to be returning a Boolean. So the in keyword returns a Boolean for my given search here. We saw in the for loop, but that's a different context. But in the case of an if statement, if I say something in a tuple or list, I'm wanting to get out of that a Boolean expression. And in this case, I'm going to be looking for a specific value inside of a list or tuple. And so I've got a value of C that I'm looking for in this tuple called alphabet. And then of course an else. So if else, I would say C is not in the alphabet. And then I can also use index to get the index of C. So if I wanted to get the specific index of where C is located in that specific list or tuple, I would simply print index C, and that would give me a value, a number, and that would tell me where it appears in my list or tuple. So let's go over to Python and take a look at this and see how it works there. Okay, I'm going to do my in and index example using these two variables that I have here for alphabet tuple and alphabet list. I'm going to start with the first example, which is going to use in. So letter, and I'm going to say is equal to input, and I'm going to say, give me some letter, a letter. Hey, Vanna, pick me a letter, something like that. And I'm going to get a letter and assign that to a variable. So first thing I want to do is test it using the in keyword. And I'm going to say if letter in, let's use my list here, in alphabet list, I'm going to print something here, print, and then I'm going to say letter, and then I'm going to add that to a hard-coded string, is in alphabet list, period. And I'm going to do an else right here. I'm going to say else. In this case, I'm just going to print the converse of this, and is not in alphabet list. And let's run this little program and see what happens. Give me a letter. Let's say B. B is in alphabet list. So it's right here in my alphabet list. And therefore it's going to evaluate this to true because that is a true statement. And it's going to print that command. Use that print command to print out this sentence. If I was to run this again and put something that wasn't in my list in the input, I would of course get this one right here, which we expect. Now I want to use index to show you something, and I'm going to make a point out of this in just a second, but let's use index real quick here. So let's do print, and then the index of the letter in, let's say, alphabet list is, and then I'm going to do a string concatenation. I need to do a cast because this is going to return a integer value. So I'm going to do index. The first thing I need to do is get my alphabet list variable here, and I'm going to do dot index, and then I'm going to supply the parameter for this particular method as the letter I inputted up there inside of my input command, which is on this line of code up here. And we can't see it because it's off the screen, but I'm going to say string to cast this returned integer back to a string so I can print it as part of this command. And then I'm going to close with the string cast, and then I'm going to close up the print command. And then it's going to say the index for letter in alphabet list is, and then it's going to simply print that out. So that's a fairly embedded command right here. So alphabet list dot index, it's got its own parameter. It's inside of a cast, which is inside of a print command. So it's fairly deep, but it's fairly concise code. So it makes it very understandable right there. So let's run this and see what happens. And I'm going to put in, let's say C. And notice what it did. It said C is in the alphabet list. The index of the letter in alphabet list is 2, which is the third item in our list because it's of index 2. But let's run this again and let's see what happens if I put in some value like P. It's going to crash. And I got an error right here because P is not in the list. Well, I know of a way that I can check to see if something is in my list. And I can use the in command to test this to see if something is in the list before I actually try to get the index of it. And this is an example of where you can use code to kind of police the input of a particular variable. And this is a good example of this because I don't want this to happen in my code. So the first thing I need to do is check to make sure that my input is actually valid input before I actually try to use that inside of my program. So to do this, I can simply modify this program a little bit by taking this line of code and putting it right here. And so what this is going to do first is check to see if my letter exists in my list. If it does exist, then it's going to print the index, and that will avoid the error that I just got right here. And if it doesn't exist, it's simply just going to print the letter does not exist in the alphabet list. So let's run this, and it's going to behave exactly like as we expect. So let's do B, and it says B is in the alphabet list. The index of the letter in alphabet list is 1. Okay, that's fine and good. And now let's try P again. P is not in the alphabet list, but I got no error because I did not get to this line of code that would have caused it in the event of a index not being available for that particular letter that I entered in for my list. So you can see here I'm using the in keyword in conjunction with index to not only check the values, check to see if it exists first before I actually try to get the values. And that's something that you'll want to do inside of your code quite a bit to make sure that your users are actually inputting good data. And there's a lot of commands like in for doing these kinds of checks. And we're going to look at a few of these in later lessons, but this is the first example that I have that I wanted to show you how you can use something to check for valid input before you actually try to do something in your code. I want to talk about two things in combination right now. The first one is a fairly easy concept to get, and that's just getting the length of a list or tuple. That's basically giving you the number of items that are in your list or your tuple. So your code will look something like this, where I have my tuple defined right here as alphabet, and I just want to get the number of items in this particular this tuple or list, and I just print that out. So I use len, and then I open paren, pass in the actual list or tuple, and then close paren, and that will give me back an integer representing the number of items in this. So 1, 2, 3, 4, 5, and 6. So the output of that would naturally be 6. So let's talk about this in combination with combining lists and tuples, no pun intended here. So combining lists and tuples can be done with the plus sign, and we've seen this for combining strings as well as doing addition. So you can use it as well to take two lists or two tuples and put them together to create a larger tuple. So if I have tuple 1 here called alphabet 1, and I have tuple 2 here called alphabet 2, I combine those together with a plus sign and then print that out, I'm going to get a larger tuple like this. So let's say alphabet is 1 right there, alphabet 2, alphabet, combine them right there, there's my plus sign. And then if I print that out, I'm of course going to get the combined effect of both of those tuples together. So let's go over to Tony and look at this. Basically what I'm going to do is take two tuples, combine them together, and show you the length of those individuals and both of those combined tuples. Okay, I've got my Tony up right here. I'm going to do a len demo. Like as I said, I'm going to go over here. I'm going to grab some sample data right here, and I'm going to take, let's use my first tuple here, and I'm going to do alphabet 1. Oops, too much. I highlighted too much there and deleted it. So alphabet 1, and then alphabet 2, and I'm going to edit these down. No, I'm going to say alphabet 1 and then alphabet 2 right here, and I'm just going to get through the last 3 items there. And let's do this. Print len, let's see, length of alphabet 1 and plus string len alphabet 1. So we can see here I've got a nested length command here inside of a cast, and then I'm using the print command to print that out. Let's do the same for alphabet 2 right here. Length of alphabet 2 right here and right here. And then I'm going to say big alphabet equals alphabet 1 plus alphabet 2. So that's going to combine those two together. And then I'm just going to copy this command right here for print. And I'm going to say length of big alphabet. And use this variable inside of my print command right there. So let's print this out. And then just for good measure, I'm going to print big alphabet too. Print big alphabet. So we can see the output of that. So let's go ahead and run this and see what we get. So the length of alphabet 1 is 3. Let's clean this output a little bit up so that it's not combined. Put space in there. Let's run that again just so that I can see it parsed a little bit better. There we go. So I have length of alphabet 1 is 3, length of alphabet 2 is 3, length of big alphabet is 6. And that's exactly what I would expect. There are 3 items in this, 3 items in this. Combine the two together, I get a combined tuple with those two tuples, smaller tuples combined to make a bigger tuple. And the length of that is going to be the combined length of both of those. So that is naturally going to be 6 here. And of course, the output of that is the A, B, C, D, E, and F of these two tuples that are combined. So again, very simple, easy to use function there with length, and quick example on how you can combine tuples or lists together for that matter in a very easy way using the plus sign. Before we go to the challenge, I want to talk about the main differences between lists and tuples. Everything that we've talked about up to this point, though, has been applicable to both lists and tuples. And the differences between these two, though, stem from the concept that we introduced at the outset of this lesson, and that was the idea of mutability and immutability, or the ability to change or the inability to change. Now, the differences between lists and tuples then is going to be extensions of that concept. So the ability to change a list is going to introduce a number of functions that are available on lists that aren't available on tuples. And that's why I have created this combined list right here. And this is my list and tuple cheat sheet that kind of expresses these new functions that we haven't talked about up to this point, but says they're not available to tuples, and that's indicated by this column right here. And we've talked about in and index and len up to this point. We didn't mention copy, but we'll look at an example of that in just a second. It can be applied to both tuples and list. But everything right here on the append, the insert, delete, remove, clear, and sort are available on lists because these fundamentally will be able to change a list. If I can change it, then it's mutable. If I can't change it, then it's immutable. So if I can change it with a function, then that would kind of violate the distinction between a list and a tuple. One might be asking, when should I use a tuple and when should I use a list? Now, generally speaking, this is a very nuanced discussion that would really do me a lot of injustice to try to explain it inside of a short video like this. And it gets down into the weeds about some ideas that exist in programming concerning mutability and immutability, when you want data to be changeable and when you want data to be unchangeable. And the primary reason for doing that is to provide protected data in some programs. And that becomes important when you want to talk about security and other things. But for most intents and purposes, one of the reasons that most people would prefer a tuple over a list is performance, because tuples don't have the extra overhead that a list has for being able to modify that list. It makes it much simpler in code, and therefore it's going to run much faster in a program than something like a list. But if you're unsure as to which one you should use, start with a tuple. And if you can't use a tuple, then go to a list. It's very easy to change it. You noticed how we had a parenthesis and we simply changed that to square brackets and it becomes a list in our code. So start with the tuples, prefer that if you can. And if you don't need a tuple and you need the functionality that's applied by a list, go to a list. So with that, let's go in and look at these other methods that are available to lists, and specifically look at how you can modify the data inside of a list using the append, insert, remove, delete, clear, and sort. And these are very useful, just kind of sundry type things that you can do on lists that are available on tuples. Okay, I'm here with my change list Python file right now, and I want to start with a variable that's an empty list. So the way to do that in Python is just to say a variable and set it to two brackets, square brackets that are just empty. There's no values in this. And then I can add some values to that. So let's do some appends to this. So append to my list. And then I'm going to go my list dot append, and then I'm going to specify some value as the parameter for the append function here. And let's do a couple of these. So let's do A, B, and C, and let's print that out. So print my list like that, and let's see what happens if I run this. And I should get a list A, B, and C. So that's using append. Let's say if I want to insert something at a specific place in my list, I can do that with the insert function. And now I'm going to do an insert. Let's say insert, and I want to do some kind of insert into my list. So I'm going to change this to D right here, and that's going to print out A, B, and D, but I want to insert some value between B and D. So the way I do that is I do an insert like this. I go insert instead of append, and I'm going to say the index in which I want to insert this at. So this is the index. So I'm going to insert that at index 2, and then I'm going to tell it what value I want to put in there. In this case, C. So what this is going to do is it's going to create a list that says A, B, and D, and then I'm going to print that out, and then I'm going to insert a value at index 2. And what's going to do is shift everything after that to the right, essentially, in my list. So I'm going to now have A, B, C, and D, and D will now be at index 3. So let's see what happens when I run this and make sure everything is working. So that's exactly what I got. So I got my list right here, A, B, and D, as expected. And then I did an insert right there, and that's going to give me A, B, C, and D. So very straightforward right there. So let's say I want to remove an item from my list by value. To do this, I simply use remove, and this is using a value removal. And we're going to look at how to delete by index in just a second. So let's say I have my list again, and I want to remove, and I just say a value. And if I remove C, it's not going to say what index I want to remove it at. I'm going to say what value do I want to remove from this list. So this should revert it back to A, B, and D once I do the remove here. So let's go right here. So A, B, and D. So simply removed the C from my list. Let's go ahead and then do a delete as well. Let's do a delete of the last item in my list. So that is going to be the D value right here. So that is index 2. So to do this, I use the delete key, or the del keyword. So I'm going to delete an item, and item. Let's just go ahead and add remove an item and insert an item right here for good comments. And I'm going to say del, and then I'm going to say what list, and I'm going to use, so my list in this case, and then I'm going to get the index that I want to remove at. So I have at this point A, B, D, so I'm going to remove the second, or the 2 index, or not the second, the third item in my list. So that's going to remove D in this case. And so if I print my list, it should just be A and B at this point right here. Let's go ahead and run that. And that's exactly what I have. I have A and B. So very straightforward example there. If I want to clear the list, I can do that rather easily. I'm just going to use clear, and that's going to wipe out everything in the list. Clear a list. It's not going to delete the list. It's just going to remove all of the values in the list. So my list dot clear. Let's just add that. My list clear, and let's just use in no parameters there. And if I print my list now, it should just be 2 brackets without any values in it. And that's exactly what we have there. And last one is sort, and that's the last one I wanted to talk about here for manipulating a list. So let's create a list. Let's call it my alphabet. And let's just put in a bunch of letters here into my list. And let's say A, not in any particular order, B, A, D, E, let's say F, and C. And that's my list. And I'm going to sort that out. So let's do my alphabet dot sort. And then I'm going to print that out. And that should sort it in alphabetical order, because that is a list of strings. So let's go ahead and run this and see what we get. I'm getting not printed my list, not my alphabet, and run that again. And there we go, A, B, C, D, E, and F. So that's basically taking those items and then sorting them out according to alphanumeric order. And let's do the same for a list of numbers right here. So just so you can see that I'm dealing with comma 5, comma 1, comma 8, comma 3, comma 1, comma 3, comma 1, comma 9. And let's sort that out. And let's call it my numbers instead of my alphabet. And my numbers, not sort, and print my numbers. And let's run that. And we see 1, 1, 1, 2, 3, 3, 5, 8, and 9. Because I have a couple of 1s in there and a couple of 3s, I'm getting redundant data. So that's one way to quickly sort something. You just call the sort command and it will sort it for you. Now that works on things that are represented accurately in like alphabetical order or numerical order. If you have something like emojis, I don't know that there is an emoji order or something like that, but it does work for things like numbers and letters or words if you're using those for your data. So this is how you can use several of these commands that are available for lists but aren't available for tuples, and these are some quick examples of how to do that. So let's go and look at the challenge, and then this is going to be using lists, and we're going to be using it for kind of a fun activity. I think that's going to kind of help you to reinforce these ideas. So for this week's challenge, I want you to create a set of playing cards. This is a 52 card deck. It's got ace 2 through 10, then jacks, kings, and queens of 4 suits, spades, clubs, diamonds, and hearts, something that we're probably all very familiar with. And I want you to create a program that generates this, or you can hard code it using the examples that we've seen already, where we just hard coded all the possible values for a given list. Now, hard coding it would be the easy way to do it. And if it was a production application, that's how I'd do it, because it'd actually be a lot faster. But if you want to challenge yourself, create a loop that loops over a bunch of numbers, say 0 to 51, and then use mathematics to figure out what the suit of a given number would be, as well as the value of that particular card would be. So if I was to say use modulus of 13, that's going to return 0, 1, or 2, or 3, which can be used to determine the suit. And if I was to use integer division, that's going to give me some value 0 through 12 that I can use to determine the value. So you can see how you could use that to populate a deck of cards. And that's the way I prefer to do it. Of course, it's going to be more challenging, but you can also hard code it if that's the way you see fit. Once you have your deck of cards created, whether you choose to use a hard coded set or you choose to use code to do that, I want you to write code that randomly draws a card from the deck and removes it. So this is going to again use random number generation, which we've seen already, and then it's going to use some of that functionality that we just saw on the previous example where I was removing something from the list. So in this case, I'm essentially picking a card at random and removing it from the deck. And then once I get that deck down to no cards, I want you to exit the program, or if the user just quits, you can quit as well. So repeat this until the user quits or the deck is empty. And for a bonus, create a program that actually shuffles the deck, or create a method or a loop that will shuffle the deck. And I want to see if you can figure this one out too, because this one also will be a challenge for folks to figure out. This one will require you to think about how you can loop over a deck and then create a program that will take something out of the deck and reinsert it at a different point in the deck. And that would, of course, be using some kind of randomization as well. So this is going to be a challenge that requires you to think about a couple of different things. Again, you can use some of the more easy ways of doing things, or you can use more and more complex ways. I'm not going to condemn you if you choose some of the easier ways to do that. I really just want you to work on figuring out how to do the requirements that are on the second and third bullet point there. That is to write code to randomly remove a card, and then do this until the user quits or the deck is empty. And that's kind of the crux of it. But the other two things would kind of be bonuses if you want to go that length. So I'm going to show you my example, and I've implemented all of these in my example so that you can see what's going on. Of course, I'm not going to show you the code, but let's go over to Tony and let you see what's going on in my example, and then you can see what I'm asking for. Okay, I've got my code pulled up here. I've called it deck.py, and I'm going to run this and show you what I'm going to be looking for inside of my challenge here. So what I've got here is my first list that I have printed out here, and it's just a list of cards that are represented by strings here. I've got a value and a suit, and I've used code to generate this. So basically I've looped over a bunch of numbers, and then I used some math to say what's the value of that, what's the suit of that, and then I've created a card that's represented by a string here. So ace of spades, and then you can see it gets up to the king, and then it starts over with the next suit, ace of hearts, ace of clubs, and then down here finally ending on the king of diamonds. So I generate the deck of cards right here, and you can do this part. This is optional right here if you don't want to do it. But this is where I shuffled the deck. So I basically took whatever this was generated, and then I shuffled it by randomly removing a card and then reinserting it back into the deck, and then moving things around at random in the deck up to a point where all the cards were shuffled. So if I stop this right here, let's say if I hit Q to not draw any more cards down here, and rerun this program. Let's rerun it again. I saw ace of spades right there. Now I see the five of spades. So I've got a new order inside of my shuffled deck. And then I can draw cards simply by pressing the enter button, and it's basically just no input. And so I can draw the cards out of the deck until the deck is exhausted. And that should happen here in just a second. I've hit the enter button quite a few times. And once I get to the last card, it simply exits the deck. So you could use something like len to determine the number of cards left in the deck, and then once you get down to no cards, you quit the loop. Or you can exit simply by hitting Q, which we saw right here. So Q, it simply quits, and that will then exit the code as well. So here is my example. You can create something like this, so you can choose what parts you want to do, of course. But basically, I want you to create a program that creates a deck of cards, however you choose to do that, and then just draws a card at random from it, or let the user hit Q and then exit the code, the program. So this is the challenge for this week. It could be really hard or really easy depending on how you want to implement it. That's up to you, how much you want to challenge yourself. But again, I'm looking forward to your submissions, and thanks for watching Cool Enough to Code this week. If you like this content, please consider liking this video, then clicking on the subscribe button to subscribe to our channel, then clicking on the bell notification icon and selecting all so that you'll get notifications when new content becomes available on our channel. You can also click on the share icon and share this video to any of your social media platforms. Sharing this helps make it more widely available for those who might be interested in coding. Also, consider following us on Twitter so you can see updates on Twitter whenever new content becomes available, as well as other announcements related to Cool Enough to Code. You can also help us out by becoming a patron on our page by going to our Patreon page at patreon.com/coolenoughToCode and then clicking on Become a Patron, and there you can find out more information about how you can support our work with Cool Enough to Code. And like always, you can check us out online at coolenoughToCode.com. There you can find a schedule of all of the upcoming lessons that we have. You can also find out more information and reach out to us online here, and you can also watch the live stream as it comes out each week on coolenoughToCode.com as well. And like always, thanks for watching this lesson on Cool Enough to Code.